Let's finish doing some of these quadratics. I want to start right there. What's the parent function? In other words, every type function has a standard parent function. What is it for a quadratic?
I'm not sure.
It's y equals x squared. That is the basic quadratic. Okay? Now, if I said graph that, give me 1 point that's on the graph.
I'm not sure.
Well, pick values for x. Any value you want, starting with 0. If x is 0, where is y?
It's also at 0?
Yeah, so that point right there is on the graph. Now give me another point. Pick another
0,
value.
1.
Pick another value for x and tell me what the y value is, and that xy coordinate is on this graph.
Okay, so x would be 1.
Okay.
So then it would be 0, 1.
If x is 1, what's y?
0.
Plug in x of 1. What's 1 squared?
1.
Huh. So 1 comma 1 is...
Oh, okay. Got it.
Okay, you with me?
Yeah.
Okay, give me another point. Remember what this graph looks like. We know it's what kind of a graph? What's it called?
A linear?
A parabola. Linear,
Oh.
linear means straight line. So it's definitely not linear. It's going to look something like either this or this over on the left. Okay, so give me another point. What, in other words, we can kind of tell that, well, we don't know yet which one of these it looks like. Give me another point. Pick another value for x and make it negative.
So it would be negative 1?
Okay, what's y?
It would be negative 1.
No, y is equal to negative 1 quantity squared. What's negative 1 times negative 1?
1.
Ah, so when x is minus 1 right there, that point's also on the graph. But y is 1. And now we know what kind of parabola it is. Is it the top one or the bottom?
The top one.
Yeah, all I got to do is draw something that looks like a parabola that goes through those 3 points. And there's my graph. Okay? Now, that's probably one of the most important graphs you can know in algebra. Seriously, is y equal x squared. Only because they spend so much time on parabolas and quadratics. Quadratics means there's a y and there's at least one x squared. And it either looks like that or it looks the other way where it opens down. Now, what's the most important point on this parabola that I've drawn?
The 0, 0.
What's that called?
The vertex?
Uh-huh. Do you see why that's the most important point?
Mm-hmm.
Because it gives you the minimum y value that you can possibly have. Notice that the minimum y value is 0. Y is never negative. No matter what x is. I can plug in any number I want for x. If I plug in -2 for x, then y is 4. And that's why this graph looks the way it does, is because y is never negative. Can't be. There's no number you can plug in for x that would make y negative. All right. Erase some of this. Whoops. Important thing to realize is that the vertex is the most important part of a parabola. The vertex being that point there. Now, if I were to draw a parabola like this, that's still a parabola, still a quadratic, but it's going to have a different equation. Okay? So,
Okay.
let's talk about transformation of graphs. Now, this is also a big subject. In other words, this is not one we're going to get done with today. Okay? It just is a really big subject. Transformations of functions. And this is not a bad function to work with. We could work with transformations of linear functions. We could work with transformations of cubic functions, which is x to the third. Or we can start our learning of transformations with this function right here, y equal x squared. Okay? Now, let's talk about what would this function look like? Y equal minus x squared.
I think it would open down.
Where would the vertex be? Give me
It would be
the coordinates, the x and y coordinates of the vertex of that function.
I think it would still be 0, 0.
Yeah. In other words, if you plug in 0 for x, you get 0. So that means the vertex is there, and it's basically just a reflection of the parent function. Now, this is called the parent function, okay? And what we're going to work with are the 6 transformations you can make of any function. And it doesn't matter if it's a quadratic function or a cubic function or a linear function or an exponential function or whatever. All of these transformations are similar in principle. Okay? So we see the first transformation where there's a negative coefficient in front of the x squared. And as all that does is gives you a reflection over the x-axis. Okay? Now, I don't want to ignore the reflection over the y-axis. If I wanted a reflection over the y-axis, I would write it like that. You see the difference?
Yeah.
This second reflection, notice that the negative sign is inside the parentheses, not out. In other words, in this function there, if x equals 2, y equals -4. And this function here, if x equals 2, what's y equal?
Say again?
It would equal +4. In other words, you would have -2 squared. -2 times -2 is +4. So this second function is different than the first function, but it looks exactly the same. In other words, you can't really tell the difference between those two functions. They look identical. But the fact of the matter is that this green function is a reflection over the y-axis. In other words, if I take this original parent function and I reflect it over the y-axis, I get the same function. You know what I mean when I say reflect over the y-axis?
I think so.
Let me give you a test on that. Let's say you have that function right there. Now, tell me which is a reflection over the y-axis. Hold on. Which of those two? In other words, is it this one or is it this one?
Over the...
Over the y-axis.
I think it's the one to the right.
You're correct. In other words, what you want to do is you want to take this image, and if I could show you putting my hand on it and reflecting it horizontally, not vertically. In other words, if I take this original image and I reflect it vertically, it looks like that, right?
Mm-hmm.
But if I reflect it horizontally, it looks like that. So there's definitely a difference between horizontal and vertical reflections. Now, let's talk about, remember this is our parent function. Now let's call that f of x instead of y. And there's a good reason for doing that. If the negative sign is in front of the f of x, then that's minus x squared. That is a vertical reflection. Vertical because the change is outside the function. If the negative sign is in front of the x like that, well, that becomes this, which actually becomes the same thing we started with. So a horizontal reflection in this case, and only in this function, is the same as the parent function. But a vertical reflection is different. A vertical reflection reflects over the x-axis, whereas a horizontal reflection reflects over the y-axis. With me?
Yep.
Okay. There's 4 other reflections. And I want to use the f of x notation. First of all, you understand that f of x is the same as y.
Okay.
It's just different notation. The one advantage of the f of x is that it tells you that the function on the other side of the equal sign is x's. It's not f of r. In other words, it wouldn't make any sense if I said f of r equals x squared. This is a function of x, and I'm telling it that that's a function of r. So that makes no sense at all. So the advantage of the f of x notation is, first of all, it tells you what kind of variable you're going to find on the other side of the equation. Okay? There's a couple of other advantages of it. What is f of 3? In other words, when I use f of x notation, I can now ask you, well, what happens if I substitute 3 for x? What is f of x? Or, what's f of 3?
6.
What's 3 squared? Use your calculator if you need to.
Is it 9?
Yeah.
Sorry.
In other words, well, that's why I want you to have your calculator in front of you at all times. I would love it if you could do these without your calculator. You could make no greater advancement in math than to be able to do that. That's the most important thing you can do in math right now, is to be able to do these single-digit problems. 3 squared, you should know. Should not need a calculator for 3 squared. Remember that 3 squared is not 2 times 3. It's 3 times 3. Okay?
Okay.
All right. So, that's one advantage of the f of x notation, is it allows you to evaluate the function at some value of x. But, okay, so we've talked about 2 of the changes you can make, which is minus f of x, which merely puts a minus sign in front of the function. And then there's f of minus x, which puts the minus x in parentheses, like that. Okay? This is a vertical reflection. You see why? And that's a horizontal reflection. And the key thing here is, if the negative sign is outside of the f of x, it's vertical. If the negative sign is inside the f of x, it's horizontal. Remember that. So, let me give you this problem here. What's f of x plus 1 equal to? Give me the function that is f of x plus 1.
X squared plus 1.
That is a vertical shift. And notice that the plus 1 is outside the function, right?
Mm-hmm.
It's not inside the f of x. It's outside of it. And therefore, it's a vertical transformation. Now, if I wanted to make a horizontal shift, I would make it f of like that. That's inside the function. Now tell me what that is. Here's our function.
I think it would be x plus 1 in parentheses squared.
Perfect. Okay? Now, there's 4 of the transformations that you can make. There's 2 more. Okay? And I'm going to write it here small. There's a vertical, let's call it a stretch, shrink. Okay? And that's going to look like this, where I have some number that multiplies the f of x. For example, if I had 4 times x squared, that's some number times f of x, right?
Yeah.
That is a vertical stretch. Just remember that for a moment. We're going to go back and graph each of these. At the moment, I'm trying to teach you the difference between vertical transformations and horizontal transformations. Okay? Here is a horizontal stretch or shrink. And that's where the number is inside the function. For example, 4x all in parentheses squared. There you go. There are the 6 transformations you can make of a function. And those are the only 6. And this is like 2 weeks worth of algebra, okay, if you were taking this in class. But notice the similarities. All of the vertical functions, all of the vertical transformations, those 3, all 3 of them occur outside the f of x, correct? That negative sign is outside the f of x. That vertical shift of 1 is outside the f of x. And this vertical stretch is outside the f of x. Now let's look at the horizontal ones. That's inside the f of x. That's inside the f of x. The plus 1 is inside the parentheses. And the last one is inside the f of x. So that's probably the most important thing you can remember, is that vertical transformations, anything that's being done is outside the function. Horizontal transformations are inside the function. Now, let's talk about the graphs. First of all, here's our function, our parent function. And there's like 10 parent functions that they want you to know. This is just one of them. X cubed is another one. Square root of x is another one. F of x equals mx plus b is another one. Each of these are different parent functions. And each one of them are going to have different kinds of transformations. Okay? So, let's talk about the first transformation. Well, in fact, let's cover all of the vertical transformations. Notice that the minus sign is outside the f of x, which is like that. That is a vertical reflection, like that. Okay?
Okay.
That's a vertical reflection. Now let's talk about a vertical shift, which is the next easiest thing, which is the original function plus some number. We'll say 3, but it could be any number. Okay? So what is f of x plus 3? If f of x is x squared, what is f of x plus 3?
X squared plus 3.
Now, remember the original function. Here, let me draw it in red. That's our original parent function right there. Okay? So now I'm going to draw this transformation in green. Where do you suppose the vertex is? Give me the x and y coordinate of the vertex.
I think it's shifted 3 over.
No, it's vertical. It's a vertical shift.
Oh, so up 3
Not
then?
over, it's not over to the right or over to the left. It's either up or down.
It's up then.
Okay. And it would be shifted exactly 3 units up. Does not change the shape. You still have exactly the same looking parabola. It's just the vertex is now at 0, 3, right? That's what that point is. In other words, all I've done is a vertical shift. If that was a negative 3, then I would move it down 3, and it would look like that. Okay? So when I say vertical, I mean vertical, not horizontal. Now, let's deal with the other vertical transformation, which is a vertical stretch or shrink. And this would be some number, we'll make it 2 this time, times f of x. Notice the 2 is outside the function. So what is 2 times f of x?
It would be 2 parentheses x squared?
Well, you don't need the parentheses.
Okay.
In other words, what I just wrote there is the same as this. In either case, the only thing being squared is the x. In other words, I'm not squaring the 2. The 2 is outside of the function. That's what makes it vertical. And there's your 3 verticals. That's it. You can only do 3 vertical transformations. I mean, I can have different numbers here. Well, not for a reflection. A reflection requires a minus sign. But a shift, notice, does not change the shape, but a stretch does. If I were to stretch this thing, still has its vertex at 0, 0, but it's skinnier. And in other words, I've changed the shape of the parabola. It's no longer the same parabola that I started with. If I go back over here and draw this parabola, it's wider. Okay? Whereas the one in blue has been vertically stretched. It's like I grabbed the two ends of the parabola and pulled them up, which is exactly what the factor of 2 does. It means however far away I was from the x-axis, I'm now going to be twice as far. So when x is 1, y is now 2, not 1. And when x is 2, y is not 4, y is 8. So the net effect is you make the parabola skinnier. Now, why do I say vertical stretch or shrink? It's because a shrink makes the appearance different. What causes a shrink is a number less than 1. In other words, how about 1/3 f of x? What function is that?
1/3 x squared.
Where's the vertex? Let's plug in 0 for x. That's always a good way to start. So what's 1/3 f of x if x is 0?
I think it's just 1/3.
It's still right there at 0, 0.
Okay.
When x is 0, f of x, or 1/3 of f of x, is still 0. Okay? But it has a difference on the shape of the parabola. It no longer is going to look like this original parabola over here on the left. It's going to be flatter. In other words, when this number right there is less than 1, I shouldn't really say less than 1, I should say between 0 and 1, then its effect is to flatten out the parabola. That's why it's called shrink. It shrinks it. Stretch, stretches it. Shrink, shrinks it. Shrink has the effect of pushing down on these endpoints. Stretch has the effect of stretching up on those endpoints. So stretches and shrinks, vertical ones, change the shape of the parabola. Remember, the reflection did not. The reflection just takes the original parabola, reflects it over the x-axis, and you get basically the same thing, only upside down. A vertical shift does not change the shape. Takes the original parabola, just moves it up or down. A stretch makes it skinnier, and a shrink makes it fatter. Okay?
Okay.
And you could, if you forgot all of this, the easiest thing to do is just to plug in some values. So let's say I told you, and this time I'm going to call it y. Y was equal to minus 2x squared. How would I graph that? And there's the original y. That's the parent function that I'm graphing right now. That's y equal x squared. So what would this, and I'll graph it in red, what would y equal minus 2? You got two transformations going on here, right? What's this negative sign there do?
It doesn't reflect it.
Over which axis? Because there's two different axes.
The y-axis.
Nope, it's outside the function. Therefore, it's a vertical transformation. Everything that happens outside the function is vertical. Well, if you look at this function and you said reflect it vertically, that's what you'd get, right?
Yeah.
Okay, that's what a vertical reflection is. But this is more than just a vertical reflection. This is a vertical reflection combined with a vertical stretch. So if I wanted to graph that, I got to do both. And I always do reflections first. The only priority in the order that you do these is that you do your reflections first. Okay? So if I want to graph y equals minus 2x squared, first if I do the reflection, which is the red line, and then I do the vertical stretch, which we know makes it skinnier by a factor of 2. With me?
Yep.
Okay. Now, again, let me put the parent function. Okay, so we know what vertical reflections do. We know what vertical stretches do. What's this look like? First of
It
all,
would
is that inside or outside the function?
outside.
So what's it, vertical or horizontal?
Vertical.
Okay, so that's a vertical. Is it a stretch or a shrink?
A shrink.
Yeah. So what's that going to look like?
It's going to be fatter.
And it's going to look, in other words, nothing else is being done to it. There's no reflections going on. There's no shifts going on. The only thing I'm doing is shrinking the curve. And notice why it's flatter. And this is important. If I take a point right there, okay? Well, what's that point? That point is 1, 1. Well, if I multiply that by 1/2, then the new point is half as close to the x-axis. It's down there. I'm multiplying the y value by 1/2. Okay? And if I carry that logic throughout, then that's why the new curve looks like that. Is because every point on the curve is half as close to the x-axis. That's what you do when you multiply it by half. Is whatever the x value is, figure out what the y value is, and multiply it by half, you got your curve. again, our parent function, and again, I want to do vertical stuff. This time I'm going to give you a combination of vertical stuff. I want to know what this looks like. How many different things do we have going on here?
3.
What are they?
It would be a vertical translation?
Reflection.
Reflection?
Over
and
which axis? Vertical.
Over the X.
Okay, vertical means a reflection over X. What else is happening here? What's the +1 do?
It would be a vertical shift.
Shift, meaning it does not change the shape. It takes whatever curve I have and moves it up 1. And finally, what does that 3 do?
A vertical stretch.
Okay, so we got to do those 3 things to our original curve. Let me draw the original curve. There's our, whoops, here, let me draw it a little better than that. It's supposed to be a parabola, okay? That's y equals x squared. Which should I do first of these 3 transformations? We've got 3 of them. We've got a reflection over the x-axis, we've got a vertical shift by +1, and we have a vertical stretch by a factor of 3. So which one do we do first?
The reflection.
Okay, so that would, let's just do them one at a time. There's the first one. Now in green, I'll do the first plus the second. What's the reflection plus the shift look like?
It's 1 to the right.
Not, it's vertical.
Oh gosh, 1 up, sorry.
Okay, because we haven't really talked about horizontal yet. But there's 3 more of these for horizontal. So I'm doing them one at a time, okay? In other words, I want to concentrate totally on the vertical transformations, and then we'll get to the 3 horizontal transformations. So the vertical shift of +1 merely takes this red parabola and moves it up 1. So its vertex is right there. So that's that part. That's with the reflection and with the shift. Now finally, in a different color, blue, let's do all 3. What's the vertical stretch going to do?
It's going to make it skinnier.
Okay, so it's going to take the green line that I'm looking at and make it look like this. Makes it skinnier by a factor of 3. In other words, every point that you see on the green line is going to be 3 times further away. Well, that's not really a good way to look at it. Just think of it as it's a vertical stretch, therefore it makes it skinnier. And as long as you do these in the right order, you'll get the right graph. Okay? Now, it doesn't matter what order you do shifts and stretches or shrinks in. What does matter is that you do all reflections first. And does it matter here? Let me think for a second. Yeah, it does. Notice that if I did the shift first, I would have this. There's my shift. Now if I do a reflection, I end up down there. Well, that's not the same place as if I do the reflection first and then the plus shift. So it definitely matters the order you do them in. And the only thing you have to remember is do all of your reflections first, horizontal or vertical. So far, we're really only looking at vertical ones. But just remember, do your reflections first. And it really doesn't matter if you have both a vertical and a horizontal reflection. You can do those in either order. And then you can do all the other transformations in their order. But you can end up with functions that look kind of like this. If this is the parent function, and I wanted to do 6 transformations of that, I could do something like this. Hold on. Well, I'm getting ahead of myself. I don't want to do that yet. Let's just talk about the 3 vertical transformations. Let me write a function. Well, I already did. When I wrote this, that had all 3 transformations, and all of them are vertical. That's outside the function, that's outside the function, that's outside the function. That makes them vertical. Now, let's talk about horizontal, because there's 3 of those also. And there's my parent function. And let's start with a horizontal reflection. Well, that's, first of all, it's horizontal, so the negative sign is inside the function, right?
Mm-hmm.
That's a reflection, a horizontal reflection. But with this particular function, the horizontal reflection looks exactly like the original function. Doesn't change anything. So with this function, y equal x squared, the horizontal reflection looks exactly like the parent function. Now let's talk about a horizontal shift, which would be something like this. You see why that's horizontal?
Mm-hmm.
Because the adjustment is inside the parentheses. And the effect on that is to move this function, this parabola, to the right by 2 units. Does not change the shape.
Wait a second.
Shifts do not change the shape, whether they're vertical or horizontal. They just move the function up or down. Now, notice that it moves to the right even though it's x minus 2. In other words, the fact that that's minus means it moves to the right. If it was y equal x plus 2 squared, that would move it to the left. Then it would look like that. Okay? With me?
Why is that, though?
What's that?
Why is that?
Well, it just is. Trust me for now.
Okay.
the original formula is x minus h, and when h is positive, it goes to the right. When h is negative, it goes to the left. So in this case right here, h is a positive 2. So it moves to the right. In this case here, h is a negative 2. Even though you're looking at a positive 2, if my standard is this, then h is negative 2. You see why?
Okay.
In other words, if I made h negative 2, I would end up with x plus 2, because I would have x minus a minus 2. So when you're doing horizontal shifts, just remember that you kind of go in the opposite direction of the sign. In other words, if it says x minus 2, you go to the right. If it says x plus 2, you go to the left. Now, there's only one transformation left that we haven't talked about, and that's a horizontal stretch or shrink. And the way you would get that is by something like this. If I put the 2 inside the parentheses, what do you think that is?
It would stretch, it would get, it would get skinnier.
Ah, you got it right. It would get skinnier, but it's not a stretch, it's a shrink. In other words, and this is a little confusing because for verticals, numbers greater than 1 are stretches. For horizontals, numbers greater than 1 are shrinks. Numbers less than 1 are stretches. So if I want to plot y equals the quantity 2x squared, that's a vertical shrink. Looks like that. In other words, it's as if I pressed on that sides of the parabola. I am shrinking it. And I am shrinking it because this number is greater than 1. If I had y equals the quantity 1/2 x squared, I need parentheses around that. Like that. Then that would make it horizontally fatter. That would make it look like this. And notice that that makes sense. Because if I were to perform this operation, I get y equal 4x squared, right? So if I were to look at it as a vertical stretch, it would be skinnier by a factor of 4. And down here, I would end up with 1/4 x squared, which would also be a fattening of my parabola. So whether you look at it vertically or horizontally, the most important thing to remember is that when you're looking at vertical, there's stretches if it's greater than 1. If you're looking at horizontal, it's a horizontal shrink if it's greater than 1. So they work in opposite manners. So it's very important that you realize whether you're dealing with a vertical shift or stretch rather, or a horizontal stretch. Because they do the opposite things. And that's it. Okay? Now, we just have a few minutes left. Let me give you an example of all 6 transformations. I think I got all 6 covered. Let's see, I've got, what's that? Tell me what that is.
Vertical translation.
It's a vertical reflection.
Oh gosh.
Remember, minus
Keep on
signs
saying.
are always reflections. They're either vertical or horizontal.
Okay.
What's
Vertical reflection.
Okay, what's that one?
It's a horizontal reflection.
Okay. What's that number? 4.
Vertical stretch.
Good. What's this number 3?
Horizontal shrink.
Very good. What's this number 2?
Horizontal stretch.
Horizontal shift. Which way? To the right or the left?
Right.
Correct. And what's that?
Vertical shift.
Okay. Well, let's see if we can graph this. And I'm just going to do it one step at a time, all in the same color. So here's my original function. Okay? So
Okay.
the priority is do all reflections first. Okay? So I'm going to do this reflection and that reflection. Well, the horizontal reflection doesn't really do anything, but the vertical reflection does. Makes it do that. Okay? And now I've done both reflections, and the only thing left to do is the 4, the 3, the 2, and the 1. Okay, well, we can do those in any order we want. So let's do the 4 first. What's the 4 do?
It's a vertical stretch.
Which makes it skinnier or fatter?
Skinnier.
By a factor of 4. Okay, now let's look at that 3. What's that 3 do?
The 3 horizontally shrinks it.
Okay, that makes it skinnier more. You with me?
Yep.
Now what's the minus 2 do?
It horizontally shifts it to the right. 2.
2 units. So I take my super skinny parabola here. I move it 2 units to the right. You with me?
Yep.
Now finally, what's the plus 1 do?
It vertically shifts it up 1.
So now I move this vertex here up 1 unit to right there. And that's my final parabola. And here's the thing, is that they're going to give you this. And they're going to ask you to graph it. Okay. Now, they won't always give you functions that have all 6 transformations. In fact, that's pretty rare. Usually they give you just a few transformations. In other words, if I gave you a problem like this, it might give you something like that. Okay, and the first thing they're going to ask you is what transformations are going on. Tell me.
It would be a vertical reflection.
which is over the x-axis.
Yeah.
And what's that do?
A horizontal shift to the left.
Good.
And then it would be a vertical shift to the left.
Vertical is always up or down.
Oh, okay, then down.
Down by 2. So you only have 3 things going on in this transformation. You have the vertical reflection, you have the horizontal shift, and you have the vertical shift. And the problems you're going to have to answer are going to be of this nature. In other words, they're going to give you a transformed function, and the first thing they're going to expect you to know is what the parent function is. Okay? So you have to look at that transformed function and figure out, I'm looking at a parent function of y equal x squared. And everything else is a transformation of y equal x squared. Now, it's not always y equal x squared. What if it was y equal x cubed? It's a different parent function. In fact, that parent function looks like this. Okay?
Okay.
Now, what if I said y equals minus x cubed? What would that look like? First of all, what is that transformation?
Well, it's a vertical reflection.
Okay, if I take this curve that I have and vertically reflect it, looks like that. See why?
Yep.
In other words, you just take every point that's there and put it an equal distance on the other side of the x-axis. In other words, I take that point and put it there, that point, put it there. What I end up with is that. Excuse me. It'd be actually better here if I used a different color for the reflection. There's the reflection. In other words, it's not a parabola with a reflection. It's the cubic function that's been reflected. All right, I just looked at my clock and I realize I've run you over again. I apologize.
Oh, it's okay.
But this was a good session. We really covered transformations. I don't think we're quite done with them yet. I want to drill you a little bit more on them. But transformations are huge in algebra. You got to know your transformations. So we'll probably spend a little bit more time tomorrow night on transformations before we move on to finding x-intercepts and vertex format and intercept format and domain and range and all these other good stuff.
Okay.
But
Have a good night.
Good session for tonight. You too, and I will talk to you tomorrow at 7, Phoebe.
Sounds good.